So this dx upon dt is equals to kfa upon xe into xe minus x. So this will becomes okay. So this is so xe minus x upon xe हा असा येतो. So therefore we write kf upon xe and remaining this one. So therefore the equations like this, we saying the equations dx upon dt is this equations after the this simplifying the equation kf a upon xe into xe minus x. So this is the equations which will becomes right. So this equations आता हे जे equations आहे या equations ला आपण काय करतोय, this equations is in the form of this dx upon dt आहे. So we this dx upon this equations xe minus x is equals to this kfa upon this xe into dt. So in the form of this equations we can write the dx upon xe into x minus x, this one equals to kfa upon xe into dt. So once we write these equations and after the integration and after, so this is the equation in the derivative form. So after the integrating the equation आता याला equation number 3 म्हणतोय. Integrating the equation number 3, then we get the equation, याचे इंटिग्रेशन्स काय होते, इंटिग्रेशन्स ऑफ dx अपॉन xe मायनस x. व्हाट इज द इंटिग्रेशन ऑफ दिस वाज मायनस ln xe minus x. So this is the integration of this figure, and the integration of this one, it is simply the integration of this one is kfa upon xe plus xe into t plus c. C is the integrating constant. C is the integrating constants. Now just simplify as per your first law of first order kinetics, simplifying these equations. आता फर्स्ट ऑर्डर कायनेटिक्स सारखं आपल्याला हे इक्वेशन सिम्प्लिफाय करायचं आहे. ओके, इथपर्यंत तुमच्या लक्षात आलं असेल. ओके, सो नाउ दिस इक्वेशन जस्ट treated as a first order kinetics and just simplify exactly with the first order kinetics. So C is the integrating constant. C is the integrating constant. Okay, this is the integrating constant C. आणि या इक्वेशन्सला आपण इक्वेशन नंबर देऊया 4. दिस इज द युअर इक्वेशन नंबर 4. If when t is equals to 0 and x is equals to 0, then the equation 4 becomes equation 4 कसं होईल, minus ln xe minus 0. आता x म्हणजे 0 आहे and kf into a upon xe into t म्हणजेच काय 0 आहे plus c. So this factor will be 0 and हा फॅक्टर सुद्धा 0 म्हणजेच काय असणार आहे, therefore minus ln this x t equals to 0 x equals to 0. So this is the factor minus आहे, त्यामुळे हा काय x e होणार, हा 0 होणार नाही, इंटू नाही आहे, सो मायनस आहे. सो मायनस ln x e इक्वल्स टू, परंतु हा फॅक्टर्स पूर्ण 0 होईल, सो इट इज ओनली c. So this is the value of c. This is the value of c. Now this value of c, याला आपण इक्वेशन नंबर 5 म्हणूया. So this value of c, so the value of integrating constant C is putting in the equation, putting in the equation this 4, equation 4. Equation 4 मध्ये जर त्याला आपण पुट केलं तर what will be the equations? Minus ln xe minus x equals to kf into a upon xe into c plus minus ln xe. So this is the equations which will come. The minus plus ek will minus will. So equation it is minus ln xe minus x equals to kfa upon xe this xe. So this equations xe into t minus ln xe. Now this equation in the form of the similar minus ln आहे minus ln xe हे जर आपण हे केलंय बाजूला काढलं तर इक्वेशन्स कसं होईल हे ln xe minus ln xe minus x, right, equals to kf a upon xe into t, right. So this is the equation. कारण हे इकडे घेतले आपण आणि याला अशा पद्धतीने लिहिले. That is this equations. आता हा मायनस आहे त्यामुळे आपण त्याला लॉग कसं करायचं आहे ln. आता हा मायनस लॉग आहे म्हणून xe upon xe minus x. ओके. ln xe minus ln xe minus x म्हणजेच काय होईल ln xe upon xe minus x. ओके. Equals to kfa upon xe into t. Thus this equation in the form of the rate of forward reactions या फॉर्म मध्ये जर लिहायचं असेल सो k f हा जर इथे घेतला असेल तर 80. ओके, हा 80 इथे येईल म्हणजेच हा वर जाईल इक्वल्स टू xc अपॉन 80 into log of म्हणजेच ln xe upon xe minus x. So in the form of this kinetic equations, these equations can be written as kf is equals to xe upon at into ln xe upon xe minus x. So this is the equations in the form of the kinetic equations, that is the kf is equals to xe upon 80 into ln xe upon xe minus x. So this equation in the form of your the logarithm to the base 10, that is the kf is equals to याला आपण 2.303 into xc upon a into t log of to the base 10 xe upon xe minus x अशा पद्धतीने लिहू शकतो. So this is your rate equations for the forward reactions. कुठल्या reactions? A converted into B. So this kf. So now this kf can be find out with the help of these equations if you know the value of A, value of t, and value of x, also value of xe. So if you know the value of all the factors, which will be easily find out the kf. So once we know that the kf value, एकदा का आपल्याला kf value माहित पडली, then this rate of kb can be find out. Rate of kb find. आपल्याला इक्वेशन नंबर 3 जे होतं काय होतं इक्वेशन नंबर 3 kb is equals to इक्वेशन नंबर 3 the kb is equals to the kfa KFA minus XE upon XE. So once we know the value of KF and put into the value of this one, initial concentrations and XE and this XE will be, we know, then we can easily find out the equation number 3, that is the backward reaction, rate of backward reactions, which is influencing the rate of forward reactions. So this is all about the value of Kf can be calculated with the help of, once we knowing the factors of X, A, Xe and T, then we can find out the value of Kf or the rate of forward reactions. So this value of X can be calculated by noting the progress of the reactions with the different time interval. Okay, so we know that very well. At equilibrium, we know that the concentration of the value of this after the time t, it is Xc at equilibrium conditions. So by substituting all the values of the Kf into this equation number 3, Kb equals to Kf into A minus Xc upon Xc, then we easily we know that the value of Kb also. So these two equations, this equation number, this is the equation number now 6, equation number 6 and equation number 3, easily we can find out the rate of velocity for the forward reactions and rate of velocity of the backward reactions, which is in more influencing on the rate of your main reactions. Okay, so this is the kinetics, which is very complicated, and we can determine with the help of this equation number 6 and equation number 3, we can calculate the rate of forward as well as the backward reaction. So these opposing reactions, these reverse reactions can be suppressed by adjusting these conditions, from which the order of forward reactions can be determined. जर थोड्याशा कंडिशन चेंज केल्या तर ही जी रिएक्शन्स आहे ही मेन रिएक्शन्स न राहता रिव्हर्स रिएक्शन्स ही मेन होऊ शकते, पण इफ यू चेंज द सम कंडिशन्स इन द रिएक्शन्स vessel, that time the opposing reactions, it is suppress your main reactions also. So in both the conditions we can find out the equation number 6 and equation number 3, so we get the Kf and Kb. So this is all about the derivations. हे एकच derivations या टोटल युनिट्स मध्ये तुम्हाला आहे, हे एकच डेरिव्हेशन्स व्यवस्थित करून ठेवा. हे एकच डेरिव्हेशन्स आहे, यामध्ये ऑप्शन्स नाही आहे कुठले डेरिव्हेशन्स विचारायला. दुसरे एक डेरिव्हेशन्स आहे ते खूप सिंपल आहे, ते डेरिव्हेशन्स तुम्हाला फारसं एवढं कठीण जाणार नाहीये, पण हे एकच डेरिव्हेशन्स ह्या पूर्ण सिलेबस मध्ये आहे किंवा ह्या युनिट मध्ये आहे. ओके, केमिकल कायनेटिक्स मध्ये हे एकच डेरिव्हेशन्स आहे जे फॉरवर्ड आणि बॅकवर्ड रिएक्शन साठी तुम्हाला फाइंड आउट करायचं आहे. बाकी रिएक्शनच्या डेफिनेशन्स आणि त्याचे एक्झाम्पल्स तेवढे असतात. ओके, नाउ व्हॉट इज द एक्झाम्पल्स ऑफ अपोजिंग रिएक्शन्स? काय एक्झाम्पल्स आहे अपोजिंग रिएक्शनचे? सो जस्ट वी सी द एक्झाम्पल्स ऑफ द अपोजिंग रिएक्शन्स and then finish this opposing or the reversible reactions. Okay, so 2 or 3 examples for the first order and the 2 or 3 examples for the second order kinetics for the opposing reactions. Screenshot कोणीतरी घेऊन मला WhatsApp करा. ओके, कोणीही घ्या, स्क्रीनशॉट करा आणि मला पाठवा. The reversible reactions for the first order reactions. काही रिएक्शन्स अशा आहेत की ज्या फर्स्ट ऑर्डर, examples of कुठलं opposing reactions, opposing reactions. आता यामध्ये फर्स्ट ऑर्डर कायनेटिक्स पण अपोजिंग रिएक्शन्स असणार आहे, सेकंड ऑर्डर कायनेटिक्स पण अपोजिंग रिएक्शन असणार आहे. अपोजिंग असणार किंवा रिव्हर्सिबल असणार किंवा त्या रिएक्शन ज्या असणार आहेत ह्या डिफिकल्टी तयार करणाऱ्या असणार आहेत. सो जस्ट वी अंडरस्टँड काय कुठल्या रिएक्शन्स आहेत. फर्स्ट एक्झाम्पल्स, जसं आपलं the reversible reactions hai, alpha D glucose is converted into the beta D glucose, right? So again beta D glucose, it is converted into the alpha D glucose. This is the simultaneous or this is the opposing reactions. ही अल्फा डी मध्ये कन्वर्ट होते. अल्फा डी हा परत बीटा डी हा परत अल्फा डी मध्ये कन्वर्ट होतो. ही रिव्हर्सिबल रिएक्शन आहे. दिस इज अन एक्झाम्पल्स ऑफ युअर फर्स्ट ऑर्डर कायनेटिक्स. हे फर्स्ट ऑर्डर कायनेटिक्स. सेकंड एक्झाम्पल्स that is this cyanide molecules, ammonium cyanide molecules, it is converted into this urea. That is, this is urea, but again this urea is converted into this ammonium cyanide. This is under reversible reaction and it is a opposing reaction. Examples of a first order kinetics. Third examples, that is the alpha hydro. This is a very well known examples. Alpha hydroxybutyric acid, that is CH2. This is the alpha hydroxy. This is the alpha positions and this is the alpha hydroxy. CH2 CH2 COOH. This alpha positions. Okay, so alpha, beta and gamma. So this is, sorry, this is alpha, beta and this is gamma. So gamma hydroxybutyric acid, this butyric acid, it is converted into lactone. Lactones means it is a simply the ring cyclic esters. Ring cyclic ester. How this is the ring cyclic ester? This is the ester. Okay, and this ring cyclic esters, it is simply converted like this. It is converted into this plus H2O. And this is ring cyclic ester. It is called as lactone. It is called as lactone. याला ester म्हणायचं नाही तर याला काय म्हणतो आपण, lactone, because this is the ester functionalities, and if the ester functionality is present in the ring, then it is called as the lactone. So this convergence again, it is converted into the alpha hydroxy. This आता इथला जो हायड्रोजन असतोय आणि इथला जो हे असते दिस OH ग्रुप, हा काय करतोय, मायनस H2O होतो इथे, मायनस H2O इथे मायनस H2O. ओके, म्हणून इथे H2O बाहेर पडतोय आणि हा H2O ऍड केला इथे प्लस H2O होतो आणि परत हा तुम्हाला अल्फा gamma hydroxy butyric acid तुम्हाला मिळतो. So this is an examples of reversible reactions for the opposing reactions. Okay, then fourth examples. This fourth examples, it is a backward or the forward reactions for the first order and backward reactions of the second order kinetics. म्हणजे काही रिएक्शन्स अशा असतात की जी फॉरवर्ड रिएक्शन असेल, फॉरवर्ड रिएक्शन ही फर्स्ट ऑर्डर असते अँड बॅकवर्ड रिएक्शन असते ही सेकंड ऑर्डर असते. दिस इज सेकंड ऑर्डर रिएक्शन. असे काही एक्झाम्पल्स आहेत, त्यापैकी हे एक्झाम्पल्स आपण बघतोय. हायड्रोलिसिस ऑफ इथाइल एसिटेट इन aqueous solutions. Hydrolysis CS3 COOC2H5 plus H2O in presence of this H plus ions. It is formations of CS3COOH plus ETOH, म्हणजेच ethyl acetate C2H5OH. This is the forward reactions, and this forward reaction, it is KF, it is first order kinetics. हा first order kinetics आहे. का बरं first order kinetics आहे? Because the hydrolysis of this one, this is a hydrolysis over here in presence of H plus. This is acidic hydrolysis. This acidic hydrolysis, what will happen here? The breaking down these molecules in formations of acetic acid and ethyl alcohols. This H2O, it is practically constant. Why? Because in large quantity, because it is a solvent molecule and it is in large quantity. Therefore, it is practically constant. And H plus ions is acid and it is the acts as a catalyst. So therefore, this reactions, in this reaction, the change in concentrations or the rate of reactions only depends on the concentration of this molecule. So the rate law for this one, the concentration dx upon dt is equals to the K into the change in concentration of CS3COOC2H5 molecules. So only this concentration, the rate of reaction depends only one molecules, that is the ethyl acetate, and therefore this is the first order kinetics. But the backward reactions, it is the second order kinetics. This KF is the second order kinetics. Why it is second order kinetics? What is the backward reaction? that is a CS3COOH plus C2H5, which will be formed in the product, this one and this one. It is converted into again CS3COO C2H5 plus H2O. So this is the backward reaction, and it is second order kinetics. This KB, and it is second order kinetics. Why it is second order kinetics? Because the dx upon dt, or the rate of this reaction, it is depends on the concentration of this acetic acid as well as the concentration of this C2H5OH. So your rate of reaction is only depend on the concentration of the two molecules, and therefore it is a second order kinetics. Okay. So this is an examples of your reversible reaction or opposing reactions. It is the first forward reaction is the first order kinetics, and backward reaction is the second order kinetics. Okay, and the third order third reaction, that is the decomposition of alkyl ammonium halide is tertiary amines and alkyl halides. This is a very simple reactions, and it is a substituting reactions molecules, and it is very well known examples of this one. Then both forward and the backward reaction, it is the second order kinetics. म्हणजे जसं तुमचं esterifications reactions आहे. esterifications म्हणजे काय असते? CS3COOH plus C2H5OH. कुठले घेऊ शकता? मिथाइल घेऊ शकता, इथाइल घेऊ शकता. esterification of acid. Acidचं esterifications करायचं आहे in presence of this H2O molecules. Okay. किंवा H3O molecules. याच्यामध्ये जर याचं esterifications करायचं असेल, so this simple molecules which will be formed ester COOC2H5 हा ester फॉर्म होतो. परत ह्या इस्टरचं जर तुम्हाला ब्रेकडाऊन करायचं असेल, तर परत तुम्हाला इथं ब्रेकडाऊन होईल इन प्रेझेन्स ऑफ H3O प्लस. ओके, हा परत तुम्हाला काय देतोय? CS3COH. म्हणजे या रिएक्शन्स मध्ये इथे इस्टरिफिकेशन होत असताना सो only the concentrations of this acetic acid is depends on your reactions only in this reactions only the molecules of this acetic acid. So this forward reaction, it is first order kinetics, and the second only this one molecule is present and it is breakdown out in presence of H3O flows. Again it is the in presence of this basic, and again it is converted into this acetic acid and alcohols. So therefore this is also the backward reactions, also the first order kinetics. So this is also the examples of the opposing reactions. And the last examples of this opposing reaction, that is the fifth examples, that is the dissociation of hydrogen iodide. Dissociation of hydrogen iodide, HI. HI is a dissociations. So it is dissociated H plus I. Again, it is combined association of HI. It is converted into HI. So this H2 is twice molecules of this one, this H2. So twice HI is converted to H2 plus I2. Okay, so this is also the forward reaction is first order kinetics, and the second, actually the H2 and I2, it is a gas. Okay, but this I2 and this molecules, it is also first order kinetics, and sometimes it is zero order kinetic, because the gaseous molecules, it does not change their concentration in the reactions vessel. Therefore the rate of reaction, it does not depends on the gaseous molecules. So it will be considered, or it will be treated as the zero order kinetics. So the forward reaction, it is no doubt it is a first order kinetics, but in case of this backward reactions, it will be first order, or it will be sometimes it is, if it is purely gaseous reaction, so all the gaseous reaction, it is zero order kinetics. Okay, so because the gaseous molecule, their concentration does not affect the rate of reaction, does not affect the concentration of the gaseous molecules, so it is treated as a zero order kinetics. So all the reaction, it is the examples of opposing reactions. All the reaction, it is examples of the opposing reactions. Here your opposing reactions, or the opposing or the reversible reaction, it is their derivations and examples will be the finish now. Tomorrow or the next lectures will be continue with the second reactions of the examples of the simultaneous reaction, that is side reactions or parallel reactions, which is also called as a competing reactions. Opposing reaction, reversible reactions ला आपण काय म्हणतो, काउंटर रिएक्शन्स. सायमल्टेनियसली किंवा सोबत सोबत होणाऱ्या पॅरलल रिएक्शन्सला आपण काय म्हणतोय, कॉम्पिटिंग रिएक्शन. ते कॉम्पिटिंग करत असतात. जसं तुमच्या वर्गात दोघ जण जर हुशार असतील तर एकमेकांना कॉम्पिट्स करतात, पॅरलल असतात. जर एखादं एकमेकांना अपोज करत असेल तर ते काउंटर चेक देत असतात, म्हणून त्याला काउंटिंग रिएक्शन्स किंवा काउंटर रिएक्शन्स, अपोजिंग रिएक्शन्सला. आणि सायमल्टेनियसली होत असेल पॅरलल, साइड वाईज, तर त्याला आपण कॉम्पिटिंग म्हणतोय. सो दिस इज अ कॉम्पिटिंग रिएक्शन्स विल कंटिन्यू इन द नेक्स्ट लेक्चर्स. जर कोणी व्हॉट्सअपला हे स्क्रीनशॉट काढा अटेंडन्सची आणि मला सेंड करा. नेक्स्ट लेक्चर्सला आपण ते बघूया. ओके, सो नाउ आय एम गोइंग टू स्टॉप द लेक्चर्स. स्क्रीनशॉट काढा आणि मला पाठवा. 40 चे 20 जण झाले. पहिल्याच दिवशी अशी टेंडन्सी तुमची बघा, 40 जणांचे 20 जण झाले. तुम्ही okay, now I am going to stop the lectures.